Hello, this is Dr. E. from Lackawanna High School giving you the 5th lecture on population. This is AP Topic 3.5, Population Growth and Resource Availability. There are basically, the learning objective is to see how resource availability affects it, and there are 4 subgroups underneath that we'll be talking about. The skills, you need to definitely be able to do math, and when you do the math, you have to show your work. So what are some of the characteristics of a population? One is size. How many are in a specific area? If it's a large population, less likely to be declining because if you kill off 50% of them, still a huge number there. Kill off 50% of 2, not enough there. How dense are the critters? For example, if you have panthers, they need a large area. For example, 12 of them per square kilometer. If it were mice, however, it would be probably 1,200 per square kilometer. The high density, there's more competition, possibility for disease outbreak because they're not wearing their masks, and possibility of depleting the food resources, especially with that many mice. Distribution is how they are spaced compared to each other. For example, if you look at trees or dandelions, they're completely and totally random. It's wherever the seeds land, that's where it's going to grow. Uniform would be something like the Joshua tree, where they have, in their roots, they give off a chemical that prevents germination of other Joshua trees. Or birds, where there is a territory when they're nesting, say penguins or other type of birds, where they don't want others to get too close, but they want to be in a group so that they are protected. Or clumped, for example, you get a small bunch of them, like the prairie dogs, where they're all clumped together for protection from other organisms. That way, one of them will be around looking around for danger, while the other ones are out doing their own thing. But again, they're in small clumps. Another characteristic is sex ratio. If it's 50-50, it's better for breeding. If there's one male and 200 females, or one female and 200 males, that's not ideal. That sometimes happens when there's a die-off, for example, a disease that attacks either the Y chromosome or something about the female, where it limits the population growth because there's not enough of both sexes. Density-dependent factors means that if there is too many of the organisms, not enough food are going to harm them, or too many organisms and there's only a certain amount of habitat, they're going to fight. Not enough water, not enough light. Disease is going to cause problems with density if they're too dense. They will limit the population growth based on their size. Small population won't experience any problems with not enough food, but a large population will. Another thing that happens is that there will be a density-independent factor. For example, things that influence the size of the population irregardless of how big it is. For example, a tornado, a hurricane, a flood. All of those are going to affect them no matter the size of the population. Example of that, of density dependent, would be food. We've got 2 types of paramecium, Aurelia and Caudatum, where basically when you add twice as much food, look what happens between level 1 and level 2. In level 1, you can see that the Aureola is at about 100 per of individuals in the area. However, when you double the food, it goes up to 195. Same thing basically happens with the other one. Now, the idea of biotic potential is if there is an infinite supply of food, infinite ability to get rid of waste, what's going to happen? It's going to be pure and simple exponential growth. That would be if you have an E. coli that can replicate every 15 minutes, Within 48 hours, if it had infinite food, infinite ability to get rid of its waste, they would have grown, and enough of them would be there that'd be about the size of the planet Earth. However, that's not realistic. There's always going to be a limit on the growth, and that's where we're going to hit the carrying capacity. Now, calculation population size, we have to have inputs and exiting. Two types of inputs would be immigration and birth. Two ways of exiting the population would be emigration with an E and death. And so the population growth is going to be number of immigrations and births minus the number of emigrations plus deaths. So for example, if we have a population of 52 elks, we have 19 births and 6 deaths in a season. 5 new elks immigrate from another location and 0 leave. What's going to be a growth rate? Remember, if you do not show your work on an FRQ, you get 0 points. So growth is how many come in plus a birth minus how many exit by immigration plus death. So it's 5 plus 19 minus 0 plus 6 equals 18 elk are coming into the herd. So the total number that are going to be there will be 52 plus 18 equal 18 will be there in the future. So, practice FRQ would be, could you calculate the population size of a wolf pack that has 14 members, 5 of them die, 3 new ones are born, and 4 of them are come into the pack from a nearby wolf wildlife sanctuary? Show your work.